More than 1 million years before modern humans appeared, a different kind of human walked across Africa's vast plains, taller, stronger, and more resilient than any hominin that came before. This species was Homo erectus, a turning point in human evolution, the first of our ancestors to break free from the limitations of earlier primates. Their emergence marks one of the most important chapters in prehistory, a moment when biology, environment, and innovation converged to produce a lineage that would eventually reshape the world. But before we jump back in, drop a comment letting us know what time you're tuning in and where you're watching from. We love seeing how far our episodes are reaching. And don't forget to hit that subscribe button. It really helps us keep bringing exciting topics here on the Primal Roots channel. Homo erectus did not appear suddenly or in isolation. They evolved gradually from earlier species of the genus Homo, likely from populations of Homo habilis or closely related transitional forms. Fossils show a clear trend toward larger bodies, more efficient bipedal locomotion, and expanded brain capacity. These changes were not cosmetic. They were responses to shifting climates, fluctuating ecosystems, and the pressures of survival in increasingly open environments. As forests retreated and grasslands expanded across East Africa, only hominins capable of traveling long distances, hunting effectively, and managing the challenges of heat and drought could thrive. The earliest fossils attributed to Homo erectus date back nearly 2 million years, making them one of the longest-lasting human species in existence. Their bodies were entirely different from the ape-like proportions of earlier hominins. They had long legs built for endurance, narrow hips designed for efficient walking and running, and strong torsos capable of supporting physically demanding lifestyles. Their height often approached that of modern humans, and their skeletal structure suggests a level of physical performance unmatched by any previous species. But the most important transformation happened inside the skull. The brain of Homo erectus averaged between 800 and 1,000 cubic centimeters, nearly double that of Australopithecus, and significantly larger than that of Homo habilis. This increase allowed for more complex cognitive processes, planning, cooperation, spatial awareness, and improved memory. These capabilities shaped every aspect of their lives, from hunting strategies to tool-making to social interactions. The appearance of Homo erectus marks the beginning of sustained technological innovation. Earlier hominins had used simple stone tools, but Homo erectus perfected the Acheulean tradition, producing hand axes, cleavers, and cutting tools with symmetrical shapes and sharp edges that required foresight and skilled craftsmanship. These tools were not improvised. They were standardized, created through repeated strikes that shaped stone into purposeful forms. The spread of these tools across continents mirrors the expansion of erectus populations and serves as physical evidence of their cultural continuity. One of the defining characteristics of Homo erectus was mobility. They were not confined to a single region like many earlier species. Instead, they became the first humans to leave Africa, dispersing into Asia and eventually reaching Southeast Asia, China, and the Caucasus. Their ability to adapt to diverse environments, from equatorial savannas to temperate woodlands, speaks to their resilience and versatility. Their migrations were not accidental wanderings. They were part of a gradual but persistent push into new ecological territories, driven by curiosity, climate shifts, competition for resources, and the inherent advantages of their physiology. The fossil record supports this narrative. Sites in Kenya, Tanzania, Ethiopia, Georgia, Indonesia, and China reveal similar anatomical traits and tool styles, indicating that erectus populations maintained core cultural and biological features even as they spread across thousands of kilometers. The presence of well-developed social structures is implied by evidence of cooperative hunting, shared food processing sites, and coordinated group movements. These early humans understood the power of collaboration long before Homo sapiens existed. Their diet played a crucial role in shaping their evolution. Homo erectus consumed a wider range of foods than earlier hominins, including tougher plant materials, roots, and larger animal prey. Hunting became more systematic, and the ability to pursue animals over long distances suggests endurance running, a rare skill in the animal kingdom. This shift toward higher-calorie foods supported brain growth and fueled demanding physical activities. Their survival depended not only on strength, but on strategy, timing, and the ability to read the landscape with precision. Another defining adaptation was their growing relationship with fire. While controlled use of fire likely developed later in their evolutionary timeline, Homo erectus is associated with some of the earliest evidence of fire use at archaeological sites. Fire provided warmth, protection, and the ability to cook food, a biological game-changer. Cooking made nutrients more accessible, reduced chewing time, and improved digestion, all of which contributed to better health and stronger bodies. Fire also extended activity into the evening hours, fostering more complex social interactions and shared spaces for communication and learning. The emergence of Homo erectus signals the dawn of human-like behavior in ways that go beyond anatomy or tools. Their long migrations imply planning and group cohesion. Their hunting strategies required communication and division of labor. Their tool-making demanded patience, skill, and teaching, suggesting the existence of cultural transmission, knowledge passed across generations rather than reinvented each time. These behaviors highlight a species with cognitive depth, capable of building traditions and shaping their environment intentionally. Life in erectus societies was not without challenges. They navigated landscapes filled with predators, endured fluctuating climates, and faced competition from other hominins. But their ability to endure hardship speaks to their adaptability. Fossils show evidence of injuries healed long before death, suggesting that individuals who could not hunt or travel still received care. Such compassion indicates social bonds that extended beyond immediate utility, forming the basis of early human empathy. Their skeletal remains also reveal the hardships of survival. Many individuals show signs of heavy wear on their teeth, indicating a diet that included tough materials or constant use of the mouth as a tool. Bones often exhibit stress markers from a lifetime of physical labor, reinforcing the idea of a species that lived through movement, persistence, and constant interaction with the environment. Homo erectus persisted for an extraordinary span of time, more than 1.5 million years. Few species in the human lineage lasted as long. During this period, climates shifted, continents changed shape, and ecosystems transformed around them, yet they adapted repeatedly. Their longevity highlights a species that mastered stability through flexibility, capable of adjusting to environments that would challenge even modern humans. As the first chapter of their story unfolds, Homo erectus emerges not as a primitive ancestor, but as a successful, innovative, and resilient species whose impact echoes across the entire human lineage. They were the first to combine physical ability, cognitive growth, technological skill, and social structure into a complete survival strategy. Their journey set the stage for everything that followed, from the rise of later hominins to the eventual emergence of Homo sapiens. Their legacy begins with their origins, but it does not end there. Understanding how they lived, migrated, adapted, and ultimately shaped human evolution requires examining the full scope of their endurance across continents and millennia. The emergence of Homo erectus marked one of the most dramatic turning points in human evolution. Unlike earlier hominins, whose bodies still retained many traits tied to tree climbing and short-range movement, Erectus carried an anatomy fully committed to life on the ground. Every structural change, from the shape of the pelvis to the mechanics of the feet, reflected a new evolutionary strategy centered on endurance, travel, and environmental mastery. They were not simply larger versions of earlier hominins. They were built for a different world, prepared to face challenges across continents long before any other human species dared to leave Africa. The transformation began with locomotion. Earlier species like Australopithecus combined bipedal walking with climbing abilities, maintaining curved fingers, flexible ankles, and wide hips suited to both ground and tree. Homo erectus abandoned this dual lifestyle completely. Their legs were long and powerful, with femurs angled to support efficient upright walking. Their knees locked during movement, reducing energy consumption. Their feet developed arches that acted as spring mechanisms, pushing the body forward with each step. These changes allowed them to travel farther than any of their predecessors, not as occasional migrations, but as part of daily life. Mobility was no longer a temporary adaptation. It became the foundation of their survival strategy. The pelvis tells an even more revelatory story. Whereas earlier hominins maintained wider hips and shorter pelvises that stabilized the body but limited stride efficiency, Homo erectus evolved a narrower, vertically elongated pelvis. This design reduced rotational movement during walking and enabled faster, smoother locomotion across open terrain. The pelvic structure also reveals critical information about childbirth. Delivering infants with larger brains required changes to the birth canal, forcing evolutionary compromises that shaped how offspring were carried, protected, and socialized. The interplay between pelvic anatomy and brain growth created a feedback loop influencing everything from parental behavior to group cooperation. Torso structure evolved in parallel. The rib cage of Homo erectus shifted from the cone-shaped form of earlier hominins to a more barrel-shaped configuration. This allowed greater lung expansion and improved breathing efficiency during long-distance running, one of the most demanding endurance activities in the animal kingdom. Few predators could remain active under the heat of the African sun for extended periods, but erectus populations could. Their bodies dissipated heat through sweating, enabled by a significant reduction in body hair. This thermoregulatory system allowed them to chase prey until the animals overheated, a survival method known as persistence hunting. This unique ability gave them access to nutrient-rich meat long before advanced hunting tools developed. The skull and brain case represent another essential shift. Homo erectus had a brain considerably larger than that of Homo habilis. Although still smaller than modern human brains, the erectus brain was reorganized in ways that enhanced planning, coordination, and memory. The frontal and parietal lobes expanded significantly, allowing better problem-solving and refined motor control. These neural developments enabled them to create complex tools, navigate long distances, remember landmarks, and strategize hunts. The thick brow ridges, low forehead, and long cranial vault may seem primitive, but they housed a mind capable of operating on a level far beyond any earlier hominin. Facial structure also evolved to suit dietary changes. With increasing reliance on animal protein and tough vegetation, Homo erectus developed strong jaws, pronounced muscle attachments, and durable molars. Their teeth exhibit wear patterns consistent with chewing fibrous plants, cracking nuts, processing raw meat, and gnawing bones. Some fossils show evidence of toothpick grooves, possibly indicating early attempts at dental care or food removal. The heavy use of their mouths as tools shaped their facial anatomy, giving them a powerful bite and strong chewing muscles that anchored along the skull. The shoulders and arms remained capable of powerful movements even as climbing became less central to their lifestyle. Fossil evidence suggests they were efficient throwers, an ability linked to hunting and protection. The rotation capacity of the shoulder joint, combined with strong upper back musculature, allowed them to launch objects with speed and accuracy. While true spears with stone tips come later in human evolution, the roots of projectile hunting may lie with Erectus, whose anatomy makes them the first plausible long-distance throwers in the hominin lineage. Hands played an equally transformative role. The thumb-to-finger ratio in Homo erectus hands allowed precision gripping and forceful strikes against stone cores. Their tool-making was not accidental. The Acheulean hand axe required knowledge of geometry, symmetry, and repeated practice. Producing a high-quality hand axe demanded both skill and planning, traits rooted in cognitive evolution. These tools spread across Africa, the Near East, and parts of Asia, remaining remarkably consistent for over 1 million years. This long-term stability highlights cultural transmission, knowledge passed across generations, not reinvented independently each time. The internal systems of Homo erectus reflect evolutionary fine-tuning. Their metabolism adapted to high-energy foods and sustained movement. Consuming meat provided dense calories essential for fueling larger brains. Their digestive system likely shortened over time, trading bulk intestinal tissue for neural development, an evolutionary exchange that required reliable access to nutrient-rich foods. Their immune systems adapted to diverse environments as they expanded across continents, encountering new pathogens, climates, and ecological pressures. Group dynamics also shaped anatomy. Fossils reveal healed injuries, suggesting that individuals were cared for by others despite temporary or permanent disability. This level of social cooperation implies that Erectus groups valued members not solely for immediate productivity, but for shared knowledge, experience, and social stability. Caring for injured members helps reinforce group cohesion, a critical survival factor against predators, environmental hazards, and resource scarcity. Their expanding brain enabled more complex emotional and social abilities. While not capable of the full emotional range of modern humans, Homo erectus almost certainly developed attachments, alliances, hierarchies, and cooperative structures. Their ability to work together, share food, and maintain group order provided them with advantages that extended beyond physical traits. These social frameworks empowered them to occupy territories far larger than any previous hominin species. Communication played a central role in this process. Full modern language did not yet exist, but Erectus likely used vocal calls, rhythmic patterns, body gestures, and early symbolic cues to coordinate activities. Their expanding brain regions associated with auditory processing and motor control support the idea of increasingly sophisticated communication, teaching tool-making techniques, tracking prey, warning of danger, and organizing group movement all benefited from structured communication systems. Their day-to-day existence included constant movement. Campsites were temporary and often located near water sources or natural shelters. They built windbreaks, gathered around fires when available, and created zones for tool-making, food processing, and rest. Their understanding of landscape patterns, animal migration routes, seasonal plant cycles, water availability, was refined through generations of accumulated knowledge. These insights shaped migration decisions and ensured the survival of groups across diverse regions. Interactions with predators shaped behavioral evolution. Fossils from Africa show bite marks from large carnivores, suggesting that confrontations were not uncommon. Yet Erectus also scavenged carcasses left by lions or saber-toothed cats, using tools to break bones and access marrow, a nutrient-rich resource inaccessible to many other animals. Their endurance and tool-making skills allowed them to secure meat even without always making the kill themselves. This opportunistic strategy expanded their diet and supported the energy demands of their growing brains. As Erectus groups moved into Eurasia, they encountered colder climates and new ecological challenges. Their bodies adapted through changes in body proportions. Populations living in northern regions developed shorter limbs and stockier builds to conserve heat, a pattern mirrored later in Neanderthals. Clothing made from hides may have emerged during these expansions, although direct evidence is scarce. Fire became more central in colder environments, offering warmth, protection, and the ability to process new types of foods. The endurance of Homo erectus as a species, surviving for over 1 million years, reflects the success of their anatomical, cognitive, and behavioral adaptations. Few other human species demonstrate such stability. Their anatomy was not a minor improvement over earlier hominins. It was a complete re-engineering of the human body, with features that persist in modern humans today. We inherited their long legs, their cooling system, their capacity for endurance, and the basic structure of our hands. In many ways, Homo erectus is the blueprint from which later humans were built. Yet their anatomy did more than shape their survival. It shaped their destiny. Their bodies gave them the ability to cross continents. Their brains gave them the tools to adapt. Their social structures gave them resilience. Together, these traits propelled them into the next great evolutionary chapter, their migration out of Africa and into the rest of the world. The global expansion of Homo erectus stands as one of the most remarkable migrations in the history of life on Earth. Long before modern humans existed, Erectus became the first hominin capable of crossing deserts, traversing savannas, climbing volcanic plateaus, navigating river valleys, and entering unfamiliar lands shaped by climates far different from Africa. Their journey marked the beginning of humanity's transformation into a planetary species. It was not a single wave of explorers, nor a single migration event. It was a continuous generational movement that unfolded over hundreds of thousands of years, reshaping ecosystems and altering the course of evolution itself. Their expansion began in eastern Africa, where early Erectus populations thrived along lakesides and river systems during a period of dramatic climatic variability. Seasons shifted unpredictably, forcing populations to search for more stable resources. As drought cycles intensified, herds of large animals moved in search of water, and Erectus followed. Their adaptations, long legs, heat-resistant bodies, endurance-based hunting strategies, and a flexible diet equipped them for the open environments that stretched far beyond their ancestral range. Curiosity, necessity, and the constant search for food pushed them toward new horizons. The earliest evidence of their presence outside Africa comes from the Caucasus region of Georgia, at the site of Dmanisi. These fossils, dating to around 1.8 million years ago, reveal a population with surprisingly diverse anatomical traits. Some skulls resemble early African forms, while others show more derived characteristics. This variation demonstrates that Erectus migrations included individuals of different morphologies, suggesting a species flexible enough to thrive under a wide range of conditions. The Dmanisi hominins lived among volcanic landscapes, open woodlands, and seasonal grasslands dominated by carnivores unfamiliar to African ecosystems. Their survival in such an environment underscores their adaptability. From the Caucasus, populations spread eastward into the expanding mosaic of Eurasia. Over thousands of generations, groups moving into the Middle East encountered environments shaped by fluctuating rainfall and alternating glacial and interglacial cycles. During wetter periods, grasslands flourished, providing corridors for movement. During drier periods, populations retreated to valleys, coastal regions, and areas with permanent water sources. These cycles acted as natural filters, shaping which groups continued onward and which remained. South Asia became one of the most significant and long-lasting centers of Erectus occupation. Fossils and tools discovered across India and Pakistan indicate they lived in monsoon-driven landscapes with unpredictable weather patterns. Seasonal rivers flooded and retreated dramatically, altering animal migration routes and forcing hominin groups to shift their territories repeatedly. Erectus developed strategies to navigate this instability, adjusting tool-making patterns, targeting specific prey, and using stone resources with remarkable consistency. The distribution of Acheulean tools across the subcontinent suggests not only survival, but long-term cultural stability. Farther east, Erectus populations reached Southeast Asia, crossing tropical forests, fertile river deltas, and unpredictable coastal regions. Their arrival is recorded in some of the most iconic fossils in paleoanthropology, the remains discovered on the island of Java. These fossils, often referred to as Java Man, demonstrate that Erectus adapted to humid climates filled with dense vegetation, intense rainfall, and dangerous predators like crocodiles and giant carnivores. Their presence on Java suggests that Erectus may have possessed primitive water-crossing abilities. Whether through deliberate raft-like structures, accidental drift, or island hopping during periods of lower sea level, their arrival on these islands marked a new frontier in hominin dispersal. In northern China, Erectus populations confronted dramatically different challenges. Sites such as Zhoukoudian reveal communities living in caves where winters were harsh and resources fluctuated with the seasons. The environment demanded new forms of resilience. Fire, though still not universally mastered, became increasingly significant. Whether they maintained hearths consistently or used fire opportunistically remains debated, but evidence of burned bones and heated sediments suggests they were familiar with its benefits. Fire offered warmth during freezing winters, protection from predators, and expanded dietary possibilities through the processing of tough or pathogen-prone foods. The migration of Homo erectus was not merely a physical expansion. It was an ecological force that reshaped the landscapes they entered. As they hunted, scavenged, competed with large carnivores, and exploited plant resources, they influenced the distribution of species. Their presence altered predator-prey dynamics, especially as they began to compete with big cats, hyenas, and other hunters. Fossil evidence shows interaction with these predators, some hostile, others opportunistic. In several regions, Erectus relied heavily on scavenging carcasses left by large carnivores, using stone tools to access marrow and brain tissue before animals like hyenas or lions returned. Their ability to inhabit diverse environments was supported by an extremely flexible diet. In Africa, they consumed grazing animals, roots, tubers, and fruits. In colder regions of Eurasia, they relied more on meat and fat-rich animals. Along coastal areas, they may have incorporated shellfish and aquatic resources. This dietary adaptability allowed them to thrive during climate cycles that eliminated less flexible species. Their metabolism and digestive system evolved to accommodate this variation, enabling survival in ecosystems as different as equatorial forests and temperate steppe regions. The pace of their migration was slow on a human timescale, but monumental on an evolutionary one. Movement occurred not through deliberate exploration, but through incremental shifts across generations. A group might expand its territory slightly each season, following herds or seasonal fruiting patterns. Over centuries, these shifts accumulated, moving populations hundreds of miles. Over millennia, they crossed continents. Young individuals born farther from ancestral regions eventually formed the foundation of new populations that no longer remembered Africa, except through inherited adaptations. Their dispersal also created population divisions. Groups separated by mountains, deserts, and rivers evolved increasingly distinct anatomical traits. This explains the wide variation seen across Erectus fossils. Java populations became more robust, Chinese populations developed regional cranial features, and African populations retained some characteristics closer to early forms. Despite these differences, shared Acheulean tool-making traditions connect many of these regions, implying a long-term cultural continuity that spanned enormous distances. Climate change played an essential role in shaping their roots. The Pleistocene epoch was marked by cycles of glaciation that dramatically lowered sea levels, exposing land bridges and expanding coastal plains. During these periods, migration routes opened between mainland Asia and islands like Java, Borneo, and Sumatra. In warmer, wetter periods, tropical forests expanded, creating barriers that isolated populations. These cycles of connection and separation impacted their genetic diversity and likely contributed to the regional differentiation observed in the fossil record. The question of how far Erectus reached remains open. Some evidence suggests they may have approached regions that would later be inhabited by modern humans, possibly extending into areas near modern Siberia. Archaeologists continue searching for tools and fossils that may reveal even greater dispersal. Each discovery extends the known range of Erectus and challenges assumptions about their capabilities. Their migration influenced not only their environment, but also their own evolution. As populations encountered different climates, selection pressures shaped their bodies. Northern groups developed adaptations to cold, while equatorial groups retained heat-dissipating body shapes. These differences demonstrate that Erectus did not merely survive environmental variation. They evolved in response to it, carving their place in nearly every landscape available to early humans. Their global expansion laid the groundwork for future species, including Homo heidelbergensis, Neanderthals, Denisovans, and eventually Homo sapiens. Without Erectus pioneers moving across continents, many of the ecological and evolutionary pathways that shaped later humans would not exist. They created the first interconnected network of human populations across the Old World. They established the behavioral and anatomical framework for migration, endurance, innovation, and adaptability, traits that would define humanity forever. Ultimately, the journey of Homo erectus is not simply a story of movement. It is a story of transformation. Their migration reshaped their bodies, minds, tool-making abilities, and social structures. It transformed ecosystems across 3 continents. It laid the foundation for the emergence of new species, including our own. And it demonstrated that humans, long before they were modern, possessed the drive, resilience, and ingenuity to cross the world. Their migrations were only the beginning. The next chapter explores how their technology and culture evolved alongside their expanding geography, revealing how a species born on African plains developed one of the most enduring tool-making traditions in prehistory. The technological world of Homo erectus stood at the crossroads of instinct and innovation. Their tools were not mere fragments of broken stone scattered across ancient landscapes. They were extensions of thought, physical records of decisions, techniques and traditions passed from generation to generation. These tools chart the beginnings of human engineering, the first blueprints of planning, repetition, and refinement. They reveal how a species, still far from modern cognition, laid the foundation for cultural continuity and technological identity, achievements that would shape all future members of the human lineage. At the heart of Erectus technology lies the Acheulean toolkit. Far more advanced than anything made by earlier hominins, Acheulean tools represent a critical turning point in human prehistory. The signature artifact, the hand axe, appears simple at first glance, a teardrop-shaped stone, sharpened along its edges and narrowed into a point. But its construction required skill, coordination, and an understanding of symmetry. To craft a functional hand axe, an Erectus individual needed to evaluate the raw material, predict how the stone would fracture, and strike with controlled force. This level of craftsmanship demonstrates not only physical coordination, but also mental planning. The hand axe was not a random creation, but a deliberate design repeated across Africa, Europe, and Asia for more than 1 million years. The persistence of this design demonstrates cultural stability. Acheulean tools remained consistent across vast distances and long periods, indicating that Erectus populations maintained strong traditions and learned from one another. Tool-making was likely taught through demonstration and imitation, requiring observational learning and memory. This knowledge formed the core of their cultural identity, and may have acted as one of the earliest mechanisms for transmitting information across generations. Although their cognitive capacities were not yet comparable to modern humans, they possessed a form of cultural inheritance crucial to their survival and expansion. Hand axes, however, were only one part of their technological world. They created cleavers, scrapers, choppers, and picks, each fulfilling different purposes. Some were designed for processing meat, others for woodworking, hide preparation, or digging. The versatility of these tools reflected the adaptability of Erectus populations as they moved across continents and encountered new environments. Their ability to shape stone according to need reveals a mental flexibility that went beyond instinctive behavior. The use of fire represents another major innovation associated with Homo erectus. While the archaeological record remains complex and sometimes ambiguous, multiple sites across Africa, Israel, and China present evidence of controlled fire dating back hundreds of thousands of years. Burned bones, charred sediments, and traces of hearth-like structures suggest that Erectus populations understood the benefits of fire, even if they had not fully mastered its creation. Fire provided warmth in cold environments, frightened predators, and expanded their diet by making tough foods more digestible. Cooking also neutralized pathogens, increased calorie extraction, and reduced the energy required for digestion, allowing more nutrients to support brain development. Whether Erectus produced fire themselves or relied on natural sources like lightning strikes remains debated, but their consistent use of fire points to an emerging relationship between humans and environmental modification. Fire represented a significant step toward controlling nature rather than merely adapting to it. This shift opened paths to future technological revolutions and reshaped the ecological niches occupied by hominin populations. Social behavior reflects another dimension of Erectus culture. Their survival in diverse and often hostile environments required cooperation, mutual support, and group cohesion. Fossils showing healed injuries imply that individuals unable to hunt or gather for extended periods were cared for by others. This behavior indicates that social ties extended beyond immediate reproductive or survival benefits. Protecting weaker members reinforced group stability and preserved knowledge within communities. These social structures contributed to Erectus' longevity as a species, supporting them through environmental challenges that might have overwhelmed less cohesive groups. Communication played a vital role in maintaining social organization. While modern language had not yet evolved, Erectus likely used a combination of vocal sounds, gestures, facial expressions, and rhythmic signals to convey information. Anatomical features of their thorax, diaphragm, and brain suggest increasing vocal control, though their range of sounds was limited compared to Homo sapiens. Their communication system was probably rich enough to coordinate hunts, teach toolmaking, alert others to danger, and express basic social bonds. These developments formed the early building blocks of language, a trait that would later define human evolution. Group behavior extended into the realm of resource sharing. Studies of animal remains at Erectus sites reveal patterns consistent with cooperative hunting or organized scavenging. Some sites show butchery marks concentrated in specific areas, suggesting that groups processed animals together rather than individually. The division of labor may have emerged during these activities, with some individuals responsible for tracking animals, others for butchering, and others for guarding against predators. This coordinated effort enhanced efficiency and ensured that food resources were used fully. The daily life of Homo erectus was shaped by the landscapes they inhabited. Campsites were often established near water sources or natural shelters, providing access to fresh resources and protection from the elements. These sites acted as hubs where groups reunited after foraging or hunting. Over time, repeated use of specific locations created landmarks in their territorial memory. These habitual gathering places contributed to social identity and may represent the earliest precursors of settled behavior. Toolmaking zones found at many sites reveal that Erectus communities designated specific areas for manufacturing stone tools. Debris from tool production, flakes, cores, and discarded fragments, forms distinct layers in the archaeological record, indicating structured organization of living spaces. Such spatial arrangement reflects a growing awareness of domestic order and emerging cultural norms about how shared spaces should function. This organization is not yet architecture, but it marks the beginning of humans dividing their environment into functional zones. Technology also shaped interactions with predators. Acheulean hand axes and cleavers allowed Erectus populations to defend themselves against large carnivores. In some regions, they competed directly with animals like saber-toothed cats, hyenas, and large bears. Their ability to process carcasses quickly reduced the time spent at potentially dangerous kill sites. Over generations, these interactions influenced behavior, leading to enhanced vigilance, improved coordination, and more strategic use of landscape features for protection. Environmental variability played a crucial role in shaping cultural evolution. During periods of climate instability, Erectus populations adapted by modifying their tool-making strategies, altering their foraging routes, and shifting their seasonal movements. Some groups developed distinct tool types tailored to specific environments, such as colder climates, dense forests, or arid plains. These variations demonstrate that Erectus culture was not static. It evolved in response to environmental pressures, producing regionally distinct traditions while maintaining an overarching technological identity. The emergence of long-distance transport of raw materials offers further insight into their cultural development. Archaeologists have found evidence of Erectus individuals carrying stone materials over tens of kilometers to manufacture tools in resource-poor areas. This behavior indicates strategic planning and an understanding of landscape resources. Transporting stone required effort and cooperation, revealing that Erectus groups planned beyond immediate needs. Their awareness of environmental distribution and resource availability marks a shift toward more complex cognitive mapping. The question of whether Homo erectus created symbolic art remains debated. Some etched shells and shaped stones from Indonesia have been proposed as early examples of abstract expression. While these artifacts are not universally accepted as intentional art, they suggest that Erectus individuals may have recognized patterns or engaged in aesthetic experimentation. If confirmed, these objects would push the origins of symbolic thought far deeper into the past than previously believed. Cultural continuity across vast regions proves that Erectus populations formed interconnected networks, even without direct contact. Shared tool-making traditions, foraging strategies, and behavioral patterns imply parallel evolution, shaped by shared ancestral knowledge. This cultural stability contributed to their extraordinary longevity as a species, allowing them to persist for more than 1 million years, while other hominin species emerged and vanished around them. Their technological and cultural innovations laid the foundation for future human development. The ability to shape stone deliberately influenced the emergence of more advanced tools in later species, such as Homo heidelbergensis and Neanderthals. Fire use paved the way for complex cooking, social gatherings, and environmental manipulation. Social cooperation set the stage for hierarchical structures, long-term alliances, and group identity. Communication systems provided a base upon which language could eventually evolve. The legacy of their culture echoes through every subsequent chapter of human evolution. The Acheulean hand axe persisted long after Erectus populations diversified into new species. Their mastery of endurance hunting influenced later strategies used by modern humans. Their social organization evolved into increasingly complex forms as new species emerged, culminating in the intricate societies of modern humanity. Homo erectus was not simply a transitional figure in the human story. They were architects of the first recognizable human culture. Their innovations were not fleeting sparks, but the foundation upon which everything else was built. Their technology shaped landscapes, their cooperation shaped communities, their ability to plan shaped cognition, their traditions shaped identity, and these developments prepared them for the final chapter of their evolutionary journey, their transformation into new human species, and the enduring legacy they left behind. The story of Homo erectus stretches across more than 1 million years, longer than almost any other human species in the fossil record. Their survival was not a brief experiment in primate evolution, but a monumental chapter that shaped everything that came after. When Erectus first emerged in Africa, they were unlike anything the world had seen. Tall, resilient, wide-ranging, and equipped with physical and cognitive adaptations that opened a new evolutionary frontier. When they disappeared, long after many of their contemporaries had vanished, they left behind a legacy interwoven into the DNA, behavior, and biology of every human species that followed. Their extinction did not mark an end. It marked a transformation. Their gradual disappearance remains one of the most intriguing puzzles in paleoanthropology. Unlike catastrophes that abruptly ended some species, the decline of Erectus occurred slowly and unevenly across continents. In many regions, they evolved into new forms rather than fading entirely. In others, they persisted while younger species emerged alongside them. The fossil record reveals that their final populations lived in isolated pockets, particularly in Southeast Asia, where the youngest known Erectus fossils date to around 108,000 years ago. At this time, modern humans had already begun spreading across Africa. Neanderthals dominated Europe, and Denisovans inhabited parts of Asia. Yet in Java, a population of Erectus lived on, surviving in ecological isolation for tens of thousands of years after the rest of the world had changed. Their decline was shaped by environmental instability. Throughout the late Pleistocene, sea levels shifted dramatically, monsoon patterns intensified, and volcanic activity altered landscapes across Asia. Many Erectus groups had thrived under stable or predictable conditions, relying on consistent hunting and foraging routes. As climates fluctuated, habitats fragmented, and prey species moved or disappeared, Erectus populations faced increasing pressure. Their tool-making traditions, though effective, lacked the rapid innovation seen in later species. Their cognitive flexibility, while impressive compared to earlier hominins, could not match the adaptive speed of emerging lineages like Homo heidelbergensis or early Homo sapiens. Competition also shaped their downfall. As newer species emerged across Africa and Eurasia, Erectus encountered hominins with more advanced communication systems, complex social behavior, and diversified tool technologies. These species exploited resources differently, hunted with greater coordination, and adapted more quickly to sudden climatic shifts. Over thousands of years, Erectus groups became confined to narrower ecological niches. Their shrinking range reflects competitive exclusion, not through violent displacement, but through a slow process of ecological replacement as more versatile species filled the landscape. But even as Erectus populations declined, their evolutionary legacy accumulated. Many researchers consider Homo erectus to be the root of nearly every later human species. Their descendants include Homo heidelbergensis, the probable ancestors of both Neanderthals and modern humans. Denisovans, a mysterious lineage known mostly through DNA, also trace part of their evolutionary foundation to erectus-like ancestors. The anatomical traits that define the human body today, elongated legs, shorter arms, efficient lungs, expanded pelvises, and precision-based hands, all emerged first in erectus populations. Their blueprint became the template for humanity. The hand axe, a tool they used for over 1 million years, represents more than a stone artifact. It symbolizes the birth of cultural transmission. The stability of Acheulean technology across vast distances suggests a capacity for learning, teaching, and maintaining tradition. These behaviors set the stage for complex language and symbolic thought in later species. The very idea that knowledge could be passed down, that techniques could persist beyond the lifespan of an individual, began with Erectus. Their social structures formed the basis for cooperative behavior in future species. The care shown to injured individuals, the sharing of resources, the organization of campsites, and the emerging division of labor all laid the earliest foundations of community. These patterns expanded dramatically in later humans, but the roots run deep into the daily lives of Erectus groups. The emotional bonds, alliances, and group identity that define human societies today evolved from these early forms of cooperation. Erectus also transformed the ecological landscapes they inhabited. Through endurance hunting, fire use, scavenging patterns, and selective exploitation of plants and animals, they shaped ecosystems in ways not seen in earlier hominins. Their presence influenced predator-prey dynamics, altered nutrient pathways, and contributed to the dispersal of certain animal populations across continents. Their ecological footprint may not have been as dramatic as that of modern humans, but it was significant enough to shape evolutionary pressures for countless species. Fire played a transformative role in their legacy. Though their mastery of fire remains debated, evidence suggests they were among the first creatures to use it consistently. Fire expanded dietary options, protected them from predators, and offered warmth in new environments. This ability to harness a natural force represented a profound shift in human evolution, a shift that eventually led to controlled fire, cooking, metallurgy, and the reshaping of entire ecosystems through land management. Erectus may not have mastered these advanced technologies, but they ignited the first sparks of humanity's relationship with fire. Their migrations reshaped the global map of human evolution. By moving out of Africa earlier than any previous species, they established the first human presence across Eurasia and Southeast Asia. These movements carved pathways that later species followed, adapted, and modified. Their expansion transformed the Old World into a network of interconnected populations. Without their initial dispersal, the later transitions into modern humans, Neanderthals, and Denisovans would have taken very different evolutionary routes. Erectus also left a genetic legacy, though its extent remains debated. Most genetic evidence suggests that Erectus contributed little direct DNA to modern humans, compared to Neanderthals or Denisovans. However, some isolated populations in Southeast Asia may retain faint echoes of Erectus ancestry through complex interbreeding among archaic species. Even when genetic traces are absent, the anatomical, behavioral, and cultural traits they developed passed on through evolutionary inheritance, shaping the biology of every subsequent species. Their final populations in Indonesia reveal the culmination of a lineage that survived dramatic environmental shifts. As sea levels rose and fell, islands appeared and disappeared, isolating groups and creating unique evolutionary pressures. The Erectus populations that endured into the late Pleistocene did so in fragmented ecosystems with limited resources. Their resilience, surviving longer than many later species, testifies to their adaptability and endurance. The end of Homo erectus was not a single event. It was a gradual fading as newer human species expanded, climates shifted, and isolated groups dwindled. Yet their disappearance did not erase their contributions. Every feature that defines the human condition — endurance, curiosity, cooperation, tool-making, migration, fire use, and cognitive expansion — traces back to the evolutionary transformations they initiated. In many ways, Homo erectus was the first species to truly live as humans. They were the first to envision landscapes beyond the horizon, the first to reshape stone into purposeful tools, the first to track prey across endless plains, and the first to survive in climates far removed from their origins. Their story is not one of primitive existence, but of innovation, exploration, and resilience. The legacy of Homo erectus continues in every step we take, every tool we create, every society we build, and every landscape we traverse. Their long journey across continents began a pattern of movement that never stopped. Their endurance forged the anatomical and cognitive foundations that define the human species. Their cultures planted the seeds of tradition, cooperation, and ingenuity. In the end, their greatest achievement was not fire, tools, or migration. It was transformation. They became the bridge between the ancient world of walking apes and the emerging world of thinking humans. They built the first chapter of a story still unfolding today, carried forward by every species that followed. And in that long chain of evolution, Homo erectus stands not as a forgotten ancestor, but as one of the most successful humans who ever lived. Don't forget to subscribe. It really supports the channel and helps us bring you more great stories.